Free-field loudspeaker measurements are often included in loudspeaker specifications. These measurements are usually made in an anechoic chamber. However, anechoic chambers are not cheap, particularly those large enough to give accurate measurements at low frequencies. This means that many engineers don't have easy access to a suitable chamber, even more so if they are working from home. With SoundCheck, you can make free-field measurements in an ordinary room without an anechoic chamber. In a typical lab, office, or even your home, here's how it's done. First, measure the near-field response of the loudspeaker using a step sign sweep, or sweep as we call it, and placing the microphone very close to the low-frequency driver. If the loudspeaker is ported, you also need to make a measurement at the port or ports. This near-field measurement is accurate at low frequencies as it's unaffected by room reflections, but it does not accurately represent the free-field response at high frequencies. Next, place the microphone in the far field and measure the time-windowed frequency response using a continuous log sweep with the time-selective analysis algorithm. The far-field time-windowed measurement is unaffected by room reflections, but it is not accurate at low frequencies as the room size limits the width of the time window and therefore the frequency resolution. Now, if you examine the two responses, you can see an overlap region in the middle where the shapes of the curves align. Using this, you can select a precise frequency to splice the two halves of the measurement together and display a response over the entire frequency range. This is implemented in several post-processing steps, which include calculating the impulse response and automatically correcting for differences in amplitude and phase. Here you can see the simulated free-field response measured using this method compared to the same speaker measured in an anechoic chamber. In fact, the simulated free-field response is actually more accurate than the anechoic chamber measurements because of its small size and 120 Hz cutoff frequency. We can also compare our measurements to the manufacturer's published data. Here we see a tight correlation across the whole frequency range, even at low frequencies, likely because a much larger chamber was used. If you want to know more, there's a detailed seminar covering both the theory and practical aspects on our YouTube channel, and a pre-written test sequence for use with SoundCheck can be downloaded from our website for free.